taken for granted. Actually, it's not. It is water resources assessment is a huge technical problem, actually. Let me just check on the chat if you have any question, and because I see something new here. No, nothing. Okay. Okay, this is fine. Good. It's particularly complicated water resources assessment for groundwater. And I already mentioned groundwater as a last resource. Actually, it's not really last because it's currently used, but I mentioned it as an emergency resource in case of droughts, because groundwater reacts to drought in more slowly, in a different manner with respect to surface water. And this is something that is also concerning, because if the reaction to water scarcity or droughts by groundwater is slower, it means that also the recovery is lower. So surface water resources, they get exhausted more quickly, but on the other end, they recover very quickly, and therefore in a way, they are less concerning in terms of recovery. Groundwater, in terms of sustainability, is more concerning, because you know, the question is, okay, we have a drought and we use groundwater, but then how long it will take before it recovers? Because if another drought occurs before the recovery, then you know, the stress is increasing, and at the end of the story, we may end up with groundwater exhausted without any significant warning. And so it is a bit of a concern. And here I want to highlight how groundwater works, because it is indeed a complex dynamics. And first of all, we need to think of groundwater as something that is trapped into the soil, and there is water flowing into the soil through the pores, etc. There are two types of water bodies underground, which are called aquifers. Aquifers are water bodies in the underground. There are two types. There are free water bodies, which means that the water surface in the underground is not confined by an impermeable layer. So you have water in the underground which is in direct contact through the pores, through permeability with the atmosphere. But water in the underground may be also confined, and it means that you have a layer at the bottom which is impermeable, which is keeping the water at a certain level, but you have also another impermeable layer which is the sealing of the aquifer, the sealing of the water body. So if you look at the figure here, let me open it in a new tab. This is an aquifer which is in a way not confined here, if you look at my mouse here, because it is in direct contact with the atmosphere through the water pores. Here the soil is permeable. At the floor, at the ceiling of the aquifer, I don't have an impermeable layer, and therefore the aquifer can be recharged through infiltration. But then, if we move in the center of the picture, you see that here, where is my mouse now, at the number 1, the aquifer is trapped between two impermeable layers, which means that there is no communication with the atmosphere through the pores. And the result is that the aquifer cannot be recharged here. Where is my mouse? So we have here the same aquifer, which is unconfined here and there, so here and here, Unconfined means that it's communicating with the atmosphere, and is confined in the central part. Confined means that it's trapped between two impermeable layers. What is the result? The result is that when you want to take water from an aquifer, usually we use wells. We dig a well. If you dig a well, you establish a communication through between the aquifer and the atmosphere, between the aquifer and humans. So this is a well. It's an artificial communication between the aquifer and the atmosphere. And water, basically, in the well, gets to a level which is determined by the pressure, in the aquifer of water. So if you look at the well number 4 here, you see that water into the well comes to a level which is close to the highest level of water in the aquifer for the principle of the communicating pipes. So if you have a static level of water in the aquifer here, where is my mouse now? Then you get water into the well more or less at the same level. Why a little bit lower? Because water flow requires some energy. So if you allow water flowing in the aquifer and up along the well, then there is some consumption of energy, and water doesn't take at the same level as here, where is my mouse? In this case, anyway, water flows out of the well spontaneously because there is enough energy to bring water up along the well and spontaneously reaching the ground. In this case, you don't need pumping. Water comes out spontaneously, and this is called an artesian well. Artesian well means that water comes out from the well spontaneously. And the aquifer, which I called confined, an artesian well can be originated only by a confined aquifer. Okay, if the aquifer is unconfined, it's not possible that water comes out from the well spontaneously. So the aquifer feeding an artesian well, which is confined, is also called an artesian aquifer. Get familiar with these terms. If you look at the well number 6, water, even if it comes from a confined aquifer, does not originate an artesian well because there is not enough energy to bring water up to the top of the well. So in this case, the well is called a phreatic well. Phreatic well may be fed by a confined aquifer or can be originated by an unconfined aquifer. Okay, let me just see if here there is another picture which is significant. And you see confined aquifer, unconfined aquifer. There are the upper limit of the unconfined aquifer is called water table. Okay, here there are no wells depicted, but I hope you understand the difference between the two aquifers. The unconfined aquifer can be fed by infiltration, can be fed by rivers, again through infiltration. Okay. I think we can skip this figure, which is a figure related to river flows and surface water. What I would like to instead show to you is, first of all, there is a a link to geoscience video, which is interesting. It describes how this aquifer works. And please, if you're interested, have a look by yourself. And what I wanted to further show you is, let's see, Artesian in Wikipedia. Artesian well. Let me see if okay, here there is another figure which is interesting, and here there is a description of the artesian well. It is using the same figure that I just showed to you, and you see the definition here. An artesian well is a well that brings groundwater to the surface without pumping, because it is under pressure within a body of rock and sediment known as an aquifer. Okay, and when trapped, the water in aquifer is surrounded by layers of impermeable rock or clay. It is known as an artesian aquifer, what I just told you. This figure is also interesting because you see how an artesian well may work. And here there is the terminology is pervious and impervious for permeable and impermeable, and this is also terminology that you should learn. And here there is a similar scheme, and let me see, this is a picture of an artesian aquifer, and you see that, I mean, it can be an important geyser of water, what we can derive from an artesian well. And here is an artesian well, a small one in Finland, and that's it. And let me now check. Let me now search for phreatic. Okay, phreatic is a term to refer to aquifers in speleology. Let me see. I think there is no phreatic zone. Probably what it's here. Yeah. And here there is a Wikipedia page on the phreatic zone, which also quantifies. This figure is nice. What is a phreatic aquifer? And forget about the aquiclude, which we didn't discuss today. If you look at the phreatic aquifer in the blue zone, which is below the brown zone is the soil, and the blue zone is the aquifer. You see that the boundary between the aquifer and the soil is called water table, and the water table is an indication of the energy of the aquifer in that point. Of course, the highest the level of water into the soil, the highest the energy, for very simple physical reasons. And the information that you can retrieve from this picture is that the aquifer is feeding the river because the water table is sloped, inclined towards the river, which means that there is a water flow in the aquifer from the aquifer to the river, because if you have a region of water with more energy, which is connected to a region of water which has a lower energy, and the energy is indicated by the height of the water table, then you have a flow from the region with higher energy to the region of lower energy. So in this case, the fact that the water table is declining towards the river, it means that there is a decline of energy from the aquifer to the river. It means that there is a water flow into the aquifer from the aquifer to the river. So the aquifer is feeding the river. If you have an opposite configuration, which is opposite configuration which means that the water table is lowering from the river to the aquifer, this configuration, which is not shown in the screen, would mean that there is a flow from the river to the aquifer. So I just wanted to get your attention on the meaning, the physical meaning of, I'm sorry, 1 second, I need to shut up the phone. I just wanted to get your attention on the meaning of the water table, the position of the water table. Okay, I think we can stop here. Just 1 second. I close the screen sharing. 1 second. Okay, stop sharing. Do you have any question?
Yes. Can you repeat the link between import-export of food and the moving of water?
Yes, yeah, good question. Good question. I'm sorry, I now can see it in the chat, and just 1 second. So virtual water. I'm looking for a figure, and let me see. Okay. So let's look at this figure. Just 1 second. Open image, new tab. So this figure is. Let me see. It's not very clear actually. Let me just go back and look for another one. I think this one is more detailed. Okay, let's see. This is a link on the virtual water trade, and here, let me just open image in new tab. Let me see. Okay, look at this figure. This figure is showing the
we don't see the screen.
Ah, yeah, sorry. Okay, you can see it now. Can you see the screen now?
No, I don't.
Not yet.
Okay. Okay, now you should see it. Okay, if you look at this figure is showing the import-export of goods from one country to another. So basically, you see that there is, let me just try to see an interpretation. You see that there are colors, and let me just see how to explain in a few words this one. Anyway, the concept is when you export beef from Brazil to United States, you are actually exporting food. And when you export coffee from Brazil to the United States or to other countries, you export food. But also when you export like a t-shirt from Pakistan to Brazil, you are exporting a good. Now, which is fine. To produce each good, you need water. And therefore, while you are exporting a t-shirt, actually you are exporting virtually the amount of water that has been needed to produce the t-shirt. So it is important to define the concept of water footprint, which is the amount of water that you need to produce a good, either a food or other type of goods like clothes, etc. By knowing the water footprint, by matching the water footprint with the network of import-export, you can reconstruct what is the volume of water that you imported, exported. And in this way, you can, in a way, move water. And to give an example, China is now importing a lot of food from Africa, from the South Africa, where they have enough water to produce food. they do that because they don't have enough water to produce the food in China, or they don't have enough land, but let's focus on water. And therefore, they are using Africa's water to produce the food that they eat. In this way, they import virtually water from Africa. This is something that is not managed, is managed by the market. But actually, it is a kind of water trade, virtual water trade. I hope it's clear.
Yes, thanks. It's clear.
Okay, thanks a lot. Any other question? Okay, good. Let me stop sharing and let me close the registration. Good. And